Let's do some collision calculations. The easiest type of collision to analyze is a perfectly inelastic collision. That's the kind of collision where two objects stick together after colliding. So here's a picture of what that might look like. Here's two balls that are heading towards each other. They collide and stick together. After the collision, they move together as one object. So the law of conservation of momentum looks like M1 V1 initial plus M2 V2 initial equals M1 plus M2 times V final. In the beginning we had two objects, each with their own separate momenta, but after the collision they have combined to form a single object whose mass is the sum of the two masses, and that's the velocity of that single object. So V final equals M1 V1 initial plus M2 V2 initial over M1 plus M2. This expression looks like a weighted average of the velocities of the two objects at the beginning. In fact, you can easily expand this to any number of objects all colliding and sticking together at the end of the collision. In general, for a perfectly inelastic collision, V final would be M1 V1 initial plus M2 V2 initial plus M3 V3 initial dot 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 divided by M1 plus M2 plus M3 plus dot dot dot. All right, let's apply this expression to a few examples. We'll start with example 6.4 from your textbook. In this example, a truck and a car collide and the bodies of the vehicles become mixed together, stuck together, and they move together as one object after the collision. So we've got a pickup truck and it's going to collide with a small car. That's object one, that's object two. And okay, mass one of the truck is 1.8 times 10 to the 3 kilograms. It's traveling to the right initially at 15 meters per second. Now the car is smaller, its mass is only half as big. (900 kilograms instead of 1,800 kilograms. And it's traveling to to the left at the same speed, 15 meters per second. So the first question your textbook asks is, what is the final speed of that system, of the car and the truck that are now smashed together after this collision? All we do is plug in those values into our perfectly inelastic collision equation. And you can try that at home, and you should find that V final is positive 5 meters per second. So let's think about what effect this collision has had on each car now, or on each vehicle. The truck has experienced a change in velocity of negative 10 meters per second. It was traveling to the right at 15. After the collision, it's traveling to the right at 5. So it's slowed down by 10 meters per second. The car, on the other hand, I'll write this out to be very clear about how we calculated it. The car's velocity has changed by 20 meters per second because it was going to the left and then collided and ended up turning around, going the other way. So this change in velocity is twice as big as the change in velocity experienced by the truck. That's because the car's mass is half of the truck's mass. It also means if you're a passenger in this car, you're experiencing twice the acceleration in this collision than a truck passenger would experience. So whatever damage or injury the riders are experiencing is probably going to be twice as worse or twice as bad in the car as in the truck. Unless the car has better seatbelts and airbags or something. So this is kind of another safety factor in collisions, the mass of the vehicle you're riding in. If you have a heavier vehicle, a more massive vehicle, and you collide with a lighter vehicle, you're going to experience less acceleration, less damage to your car. All right, and in part C, they ask us to calculate the change in kinetic energy of the system during this collision, meaning KE final minus KE initial, which would be 1/2 mv final squared, where that's the mass of the two connected objects after the collision. And KE initial is each of these separately. Because they weren't touching yet before the collision. They each have their own kinetic energy. And what you find is that this is a pretty large negative value. That negative value means that the kinetic energy of the system after the collision is less than it was before. The objects have slowed down, essentially. kinetic energy is not conserved in this collision, where did that energy go? It went into heat, it went into sound, it went into plastic deformation of the vehicles. The vehicles are damaged now. That's where some of the energy went.